Hello and welcome back to the Maths Behind Economics YouTube channel. Now we have covered every one of the exponent rows, or sometimes called identities, or even laws. So now I would like us to do some more practice questions. You might ask, why do we do more practice questions when we practiced every single one of the rules? Well, in most cases, when you're going to have to apply them, you won't be told which rule to use, and very often you're going to have to use many of the rules in a particular example or question. So I'm going to give you 3 videos when we're going to practice the rules in a mathematical form, and I'm going to make 3 more videos when we use those same rules but with letters or variables that are more specific for economics. So let's get started. In this video today, I would like us to still see every single one of the rules. That's why I have them listed here. So if we're not quite sure what to do, we can always consult these rules. However, in the following videos, we're not going to have them up on the screen, but tell you which rule I'm using. Okay, so let's look at the first example. What we're going to do is minus 3x to the minus 5a and x to the 8a. So what's going on in this example? Well, I have got quite a few different ways to solve this question. First, I could apply the negative power rule because x is to the negative 5a. Or I could realize that there is the same bases, x, and they are multiplied together, so I can just simply add the powers together. I think I'm going to go with the second one. So, minus 3, I can't really do anything with it because there's no other numbers. But x is now minus 5a plus 8a. Now, so what can we do at the top in the exponent? Well, minus 5a plus 8a just makes 3a. So the exponent itself becomes 3a. And we can now make the simplification minus 3x to the 3a. Now, if you like to challenge yourself, I suggest that you go down the other route that I mentioned. So try to apply the negative rule in the first instance and then see whether you get back to the same answer. Second question, 2a to the x over y, a to the 2x over y. Now, here, both of the powers are positive and they are the same base. So there is only one rule I can use here, and that is the first one in here. When we multiply the same bases, we add the powers together. So a x over y plus 2x over y. Now, what's happening in here? Well, we have to add fractions together, but the difference here is now that these are fractions with variables. I'm going to use a different color, and I'm going to write out x over y plus 2x over y down here, so we can work on the fraction question separately. So how do we add fractions together? Fractions can be added together if they have got the same denominator. Now, we are very much in luck because both of the fractions have got y as the denominator, so the common denominator will be y. But what happens in here now, because they have got the common denominator, I can just simply add the numerators together, the top numbers together. So x add 2x, I'm going to make it 3x. Now I can use this result and go back and carry on with my original problem. So 2a to the 3x over y. Let me remove the side note so we got more space to carry on with our calculation. We could simply leave the answer as it is. However, sometimes you might want to be able to see the root. We could use the last identity here, and we could have one more step and rewrite a as a mixture of roots and powers. 2 is not raised to any power, so 2 is going to stay outside. Then we now have got a root, and a will be to some kind of power. But what will be the root and what will be the power? Remember, when you look at the fraction, what is at the bottom, what is the denominator? That's always the root. So in our case, y is at the denominator. So for us, y is going to be the root. So let's write y into the root. And what is at the top, or what's the numerator of the fraction, that's going to be the power. So we're just going to write 3x to the power here. Next question. I've got y to the 3b over a multiplied by y to the minus a over b. Right, what are we going to do here? Now I spot that they are the same bases, y and y. They multiplied together, but one of them is the negative power. Well, because in the first example, we've chosen to do the adding the powers together instead of using the negative. In this example, I would like to show you what to do if you were to use the negative power. So let's rewrite this. So y 3b over a multiplied by, now, negative power. What's going on in here? Well, I have to remember that this is the rule that I'm using now. So that's going to be 1 over y to the very same power, but with a positive sign, in this case now, a over b. So what's going on here? I've got something that needs to be multiplied by a fraction. Well, in this specific case, what I need to do is just multiply this by the numerator of 1. So that's going to give me y to the 3b over a all over y to the a over b. Now, what's going on in here again? I've got two exponents with the same base, but now they divided together. So in this case, I'm going to have to use this rule as well, the division rule, which tells me now that I have to do 3b over a minus a over b. In the exponent, now I have got a difference of two fractions. So let me change colors again and then work out what's happening up in the exponent. Now, I'm not as much in luck as I was in question 2 because now the denominators are different. So how do I subtract two fractions? I have to make them to be the same denominator. What would be the common denominator in this case? Well, I don't know what a is, I don't know what b is, so I'm just going to have to multiply them together. So ab and ab. In the first fraction, I'm missing b from the denominator, so I have to multiply the numerator by b again. So 3b times b, that's going to give me 3b squared, because b times b is b squared, as we established in the first video. So what's happening here with the second fraction? From the second fraction's denominator, a is missing, so I'm going to have to multiply the numerator by a as well. What is a multiplied by a? That's a squared. And now I can write this as one whole fraction, 3b squared minus a squared all over a times b. So now I can replace the numerator of y with this, 3b squared minus a squared over ab. Since we don't need that fraction anymore, I have cleared some more space so we can write the result further. Last thing that we can do here, if we wanted to, we can rewrite this as a root. Well, sometimes it makes sense to rewrite this as a root, sometimes it may not. So in some cases, you might just leave it as it is. But in this case, just for the sake of practice, let's rewrite this. Again, what's going on in here? We need to remember that the bottom in the fraction in the exponent is the one that's going to make it to root. In our case, that's ab, so ab going to be the root. So let's write out the root. I have got y, and then now I'm going to have to write ab to the root. And what stays into the exponent of y? 3b squared minus a squared. Now, if I want to do one more step, because I don't like the convoluted expression in the power of y, what I could do is write a root, and remember that if there is a difference in the power, I can rewrite this as a division of the same base powers. So I can write y to the 3b squared over y to the a squared. Now, this may or may not be simpler. It really depends on the kind of work that you're doing. So I'm going to leave it there. As I've got two more questions that I would like us to do in this video, I'm going to make some space so we can write them again without having to lose the rules. Right, now that the board is nice and clear, let's look at the next example. X to the b, and that's raised to the minus 2a times x squared. Okay, so what's going on in here? Well, the bases are the same, both numbers are x, but since we got a bracket in here, that's going to be our priority. So what rule are we going to use now? We're going to use this rule when we're raising a power to another power. So we have to multiply b and minus 2a together. Therefore, x is going to be the power of minus 2ab, and then we multiply that with x squared. Well, what's the next rule we're going to use? Well, the same base powers are multiplied together. So what we're going to have to do is keep the base of x and then just add together the exponents. So minus 2ab plus 2. Well, I could stop here, but what happens is I don't really like to have the negative numbers. So what I could do is I could switch, because addition, I can switch the order of. So I can write this 2 plus negative 2ab b. Now what we have in the exponent is adding a negative number, but that's basically the same as taking away a number. So the final result will be x to the 2 minus 2ab. Now if you want to leave it as it is, fine, but then again, if I wanted to do, I could apply this rule backwards, the subtraction of the powers rule, and I can write it as x squared over x to the 2ab. Well, again, as in the previous example, sometimes you might want your answer as a base with just one power, but sometimes you might want to work with the fraction. It will depend on what you want to do next. So, last example, y to the negative 2 raised to the 6th power, and then y to the 4th cubed. So what are we going to do here? Well, I have got two brackets, and what I've noticed is that there's a power raised to another power. So we're going to use this rule first. Okay, so y to the negative 2 to the 6, that's going to be y to the negative 12. Then y to the 4 cubed is going to give me y to the 12. Okay, so what's going in here now? I have got the same bases, multiply them together. So I'm going to have to add the powers together. So it's going to be y minus 12 plus 12. Well, negative 12 add positive 12, that's just going to give me 0. And now what I've noticed is that I can use this rule, which tells me that any number to the 0 power is always equal to 1. I hope you were able to follow through with these rules and that now you start to have some ideas of what to use and when. See you in the next one.